Hi, welcome back to Volume by Cross Sections. For this example, we're going to look at like an AP type style question. And they're saying, let R be the region bounded in the first quadrant by the graphs of y equals x cubed. That's this little cube function right here. Y equals 8, which is our line right here, and x equals 0, which is just the y-axis. So we're going to shade that region in. We want to shade this region. There it is right there. That's the region we're going to be looking at right here. And we're going to answer some questions on this. So question number one, it says first, find the area of R. Now to get the area, it's really easy. This is just our rectangle of mathematics. So starting from, I just want to find the part between them. So there's my rectangle of math right there. Now, if I draw that out over here, the skinny part's going to be dx. We are vertical, so we're going to be in terms of x. So top minus bottom. The top is our line up here, which is just y equals 8. The bottom of our rectangle is our cubic function, y equals x cubed. I'm going to put that in there too. So if I want to find the area, we're just going to multiply those together. 8 minus x cubed dx. And don't forget, now that's just for one tiny little rectangle. We're going to add up an infinite number of them, so we're going to integrate that. And where do we go from? Well, we want to know where the x's go from, right? So x's go from 0, and I got to find out, of course, where these meet. So let's see here. Where do they meet? Where does x cubed equal 8? X is just 2. So starting at 0 and go to 2. Integrate this one. It's not that bad. 8x minus x to the fourth over 4 from 0 to 2. And this just becomes, using your FTC, what's that? 2 times 8 is 16. 2 to the fourth is 16 over 4. And if you plug in the zeros, that's just easy. That's just 0. So whatever 16 minus 16 over 4 is, and you just leave that alone. And there's your answer. Look how easy. Area is easy. Don't miss area. Area is fun. We got area nailed. All right. Now, part B, this is our new stuff. This is our cross-section stuff. So now it says, let this be a solid whose cross-sections are squares. Now, we're going to be perpendicular to the x-axis in this one. It doesn't say that, but it does have to tell you. So I forgot to do that. So perpendicular to the x-axis. Same thing for part C. X-axis, perpendicular to the x-axis. Has to be perpendicular. For this one, perpendicular to the y-axis, it gets a little bit tricky, but we'll talk about that tomorrow. So here, set up, oh, my favorite phrase in all of mathematics, do not evaluate, an integral that can be used to find the volume. So they're talking about squares. So this is a cross section, not a revolution. So be very careful, we solve it differently. So what they're saying is that we are going to use our base region here, and we are going to build up from it in 3D square. So I would make a square the same height as this length is that I'm drawing right there. So if I draw my square, it's hip to be square. There it is. There is a square. The base is just our bottom part down here, which we said was just this 8 minus x cubed. It's a square, so it has a height of 8 minus x cubed as well. Not 8 times 8. There we go. Minus x cubed. So to get the volume, if you remember from before, it's area of the base times the height. So ready to get the area of the base? Oh, it's a square, so it's just whatever side we have is cubed squared. Remember, area of a square is just s squared right there. Times the height. Well, what's the height always going to be? That's right. In this case, dx. So I'm going to make this look a little bit prettier. So to get the volume, it's going to be this 8 minus x cubed squared dx. But remember, that's only for one tiny, 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 infinitely tiny little square right there. We have infinitely many of them. So we would now evaluate that as an integral from 0 to 2. And that's all we do. All right. The next one, let's take a look here, part C. Part C does the same thing, but now our cross sections are equilateral triangles. So we can use that equilateral triangle form. So if I draw my equilateral triangle, just like we did in the second video, it's all about the base today, no trouble, minus x squared. We know that the area of an equilateral triangle is 1/4 s squared, the side squared, and we know that's our side. So to get the volume, it's area of the base times the height. Area, 1/4 s, 8 minus x squared. Whoop, this should be cubed, not squared. Let me fix that real quick. That should be cubed. There we go. Cubed squared. And height, that's it, just dx. So I'm going to make it a little nicer looking. We would get 1/4, and I'm going to keep that on the outside because it's just a constant. 8 minus x cubed squared dx from 0 to 2. Same bounds as all the others. There we go. Look how easy this is. So, I mean, cross sections are really, really, really easy for us. All you have to do is just, if you know how to get the area of the base, that bottom, that rectangle of mathematics just becomes the side of our cross section. And that's really what's going on here, is that becoming the side right there. So let R, next one, again, be a cross section whose area are semicircles. So if I draw a semicircle here, be careful. This one's a little bit tougher. It is a little bit harder here. So if I draw my semicircle, like so, there it is. There's my base, which we know is 8 minus x cubed. Now the area for a semicircle, we told you, 1/2 pi r squared. So we got to find our radius. Be careful. This is our diameter. This is a little bit trickier. So therefore, to get the radius, we take half of that 8 minus x cubed. And there's our radius. So if I want to find the volume, area times the height, 1/2 times pi, our radius, 1/2 8 minus x cubed squared. There it is, dx. Now, we are not evaluating this one, so which is nice. So we're just going to write our integral here. So I'm going to put my little integral sign. Whoop, let me not put it there. What I'll do is I will put it here. 1/2 and pi are constant, so I'm going to keep those on the outside. And this is going to go again from 0 to 2. And there's our answer. I can clean this up a lot, 1/2 pi. On the inside, if I distribute, this is just 1/4 8 minus x cubed squared dx from 0 to 2. If I wanted to clean up a little bit, but you don't have to. All right, part C. Now this is where the AP comes in. Now part C says, all right, smarty pants. So you're able to do those, which is pretty easy. Now, right, but again, do not set up my favorite phrase in mathematics, an integral that gives the volume when r is rotated. So this is our revolution problem about the x-axis. So I'm going to go ahead and kind of sketch my image here. I'm going to kind of sketch that out here. So let me see if I can do something real quick. Ready? Copy. I'm going to bring that down here. Paste. There it is. Oh, messed up. Never works for me. So you know what? I'm just going to draw it. Looks kind of like this. There's our 8. And there's our region. We want to measure this to the x-axis. We're going to go about the x-axis. So you might be thinking, oh, this is either my disc or washer. It's our disc washer method. And in this case, if we go from the axis of revolution and measure straight up to here, this is going to be our outside radius. So I can say my radius of my outside, again, top minus bottom, so it's going to be 8 minus 0. This is my washer, so I got to do an inside radius as well. Starting at the very bottom, measure to the function. There it is. That's my inside. It's my hole when I revolve it. And the top there is our function, which was, what was it, x cubed? Yeah, y equals x cubed minus 0. Remember, the bottom here is my axis of revolution. We're going to measure to the axis of revolution. Right there. So to get my volume now, pi r squared h. Remember, this is not a cross section. This is now our disk method, which is pi r squared h. Volume of the out minus the volume of the in. If you want to use that formula, you can. It's just quickly pi. The volume of the outside is just going to be 8 squared, and the volume of the inside is just x cubed squared dx. And simplify this, this goes from 0 to 2 for our domains. Same as all the others, because we're going from 0 all the way to 2. And there is our answer. All right, hope you enjoyed these videos. If you did, smash that like button, and I'll see you tomorrow for day 2.